Okay, so how well do you actually understand trigonometry? Well, if you're pretty good at trigonometry, this should be a very easy problem to solve without the aid of a calculator. All right, so let's take a look at the problem. It's pretty straightforward. We want to find the sine of 315 degrees. Now we have a multiple choice question here, and let's take a look at our choices. So A is 1 over the square root of 3. B is negative square root of 2 over 2. C is 6 over the square root of 2. And D is negative 2 times the square root of 3. All right, so once again, no calculators, but if you can figure this out, go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second. Then, of course, I'm going to walk through exactly how to solve this problem step by step. And for those of you that are taking trigonometry or want to learn trigonometry, knowing how to solve a problem like this is an absolute must know. This is a critical skill that we're going to be talking about here, kind of the fundamental skill, let's say, of trigonometry. Okay, so you definitely want to stick around if you're like, hey, Mr. YouTube Math Man, I don't even know what to do here. Well, if you stick around for a few minutes, you'll know exactly what to do. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, now some of you might be saying, hey, why do we have to do this without a calculator? Because I can just simply go to my calculator and find that sign button and plug this in, and voila, you'll have the right answer. Well, indeed, you can do that, but when you study trigonometry, you have to learn how to find the trigonometric ratios like sine or trigonometric functions, sine, cosine, tangent, cosecant, secant, all these different things without a calculator. It does require a little bit of work. Of course, I'll show you all of this in just 1 second, but let's take a look at the right answer. The correct answer here is negative square root of 2 over 2. All right, now if you got this right, you definitely get a happy face, an A plus, a 100%, and a certificate of excellence because you appear to be a certified professional expert in the area of reference triangles. All right, and what we're going to have to do here is build a reference triangle on the XY plane, and we're going to do some kind of some basic trigonometry. We're just going to have a lot of fun in this problem, but I assure you, none of this is beyond your ability to understand. All right, so here is our problem. Now we are talking about basic trigonometric functions, right? Sine, cosine, and tangent. And I need to kind of assume that you have some sense of basic trigonometry. Now, typically, you're introduced to trigonometry in most kind of geometry courses. So I'll talk about like high school level math and kind of do it up here. Typically, you start off with like Algebra 1 or first year algebra. Then you move on to geometry, and then typically algebra 2, and then you take a class like pre-calculus, which is typically where you're going to study your more advanced trigonometry, kind of like the stuff that we're doing here. But in geometry, in most geometry courses, you're introduced to basic right angle trigonometry, right? So if you're taking a pretty good geometry course, right, you're going to learn some basic trigonometry. You're going to learn what sine, cosine, and tangent is. So hopefully you have some sense of sine, cosine, and tangent. If you don't, no big deal. I think you'll still be able to understand the solution. But if you do, you'll totally get the solution. But again, this is where you typically study trigonometry. Back in the good old days, you used to take trigonometry as a full semester course, but that's really not so much the case. It's pretty much taught within classes like pre-calculus. All right, but if you're facing this problem on some sort of math test or exam, what should you do? Well, if you're thinking to yourself, I know what I'm going to do, Mr. D2 Math Man, I'm just going to take a guess. Indeed, that's what you should do. Always take a guess. And if this looked pretty good to you, well, that is correct, right? So if you got the answer right for guessing, well, that's fantastic. But if this wasn't a multiple choice question, obviously we'll need to know how to solve the problem. But let's just talk about these answers right here, okay? These answers don't look too good for what reason, right? Would you really select these answers? Well, hopefully you wouldn't, because we really don't want to have square roots in the radicals like this. These need to be cleaned up a bit, like 1 over the square root of 3. We have to rationalize this by multiplying the numerator and denominator by the square root of 3. So if you look at, if you're looking at these and you're like, well, these aren't even in correct form, these need some work, well, that's good. You can eliminate these, and now you're down to these two choices. So that would be good logic. But anyways, let's go ahead and get into the math because we have a decent amount of things to cover here. And the first thing is we're going to take a look at this problem. And this is not the problem of sine 315 degrees, but it's going to be a good starter problem here because we need to get some basic kind of terminology down. All right, so what we're looking at here is a lovely XY plane, and we need to talk about angles, okay, in trigonometry, and an angle in standard position, all right, and this is typically the way you're going to measure an angle. You're going to measure it in standard position. So what you have is what we call an initial side, okay, an initial side, and that starts on the x-axis, the positive x-axis. So that we call this right here the initial side, and then we have this side right here. This is called the terminal side. Okay, so we have this right here, and then this angle is basically going to be measured counterclockwise. So we're going to go from the initial side to the terminal side where the angle ends. All right, so we have some angle here. We don't know the angle. It could be like 120 degrees or whatever. That's really not important. What I want you to just kind of get familiar with is that, hey, we have an initial side, and then we have a terminal side of an angle in standard position, and the vertex of that angle is at 0, 0. Okay, it's at the origin. Now, let's suppose we wanted to, find the sine, cosine, and tangent of an angle. We don't know what the angle is, but an angle where its terminal side goes through the point -3, 4. All right, so here is -3 on the x, and here is 4 on the y. So this point here is -3, 4. This is an ordered pair. Okay, so we're talking about an xy ordered pair here. This is a location. So the question would go something like this. Tell me the sine, cosine, and tangent of an angle whose terminal side goes to the point -3, 4. All right, so we're going to talk about how to solve this question here, and this is going to kind of basically allow us to figure out the sine of 315 degrees. All right, so let's go ahead and get into this right now. So what we want to do is build a right triangle situation. Okay, so -3, 4 means -3 on the x, right? So this is an ordered pair, -3. That's our xy again. Okay, so xy ordered pair. So x is -3. This is -3 on the x, and y is 4. Okay, positive 4 on the y. So that's this right here. So we're going to just kind of construct a right triangle, and now the terminal side is going to act as the hypotenuse of this right triangle. Okay, so we can figure this out, but we're going to refer to the hypotenuse as the radius, right? So we really have an XY situation with a radius kind of emanating out, and that radius can be a certain length. Now, how can we determine the length of this radius? Well, if you're saying, hey, Mr. YouTube Math Man, you can use the Pythagorean theorem, well, you would be absolutely correct. We can use the Pythagorean theorem. But here, the Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the hypotenuse, but we're not going to call the hypotenuse c. We'll refer to it as r, but this is x, and this is y, and this is r, so we can just have a version of the Pythagorean theorem so we can figure out what the hypotenuse is. All right, so let's go ahead and do that right now. So we have r squared is equal to x squared plus y squared. So r is going to be equal to, now what I'm doing here is using the Pythagorean theorem to calculate this distance right here. Okay, so again, for those of you that have some basic geometry knowledge, if you have a right triangle like so, and this is 3, that's a terrible right triangle, that's a little bit better, 3, 4, 5, remember 3 squared plus 4 squared is equal to 5 squared, right? So this would be like A, this would be B, and this would be C. But in our situation here, this is going to be like X, this will be like Y, and this is R, right? So in this case, we have this relationship in only right triangles. So 3 squared is 9, plus 4 squared is 16 is equal to 5 squared, which of course is 25. 25 is equal to 25. All right, so we can solve for the hypotenuse here by just getting the square of this, getting the square of that, adding it up and taking the square root, and we will get r. All right, so that's what I'm doing right here. And when I do all this lovely number crunching, we see that r is equal to 5, right? Just pretty much like a standard 3, 4, 5 right triangle. Although we have -3 here, it's still 3 in terms of its distance, right? So this is 5. Okay, so this is what we have now. We have this situation. So here is our angle, okay? Its terminal side is going to the point -3, 4. And now we have all the sides of the triangle, right? So this is -3 here, this is 4 here, and the hypotenuse is 5. All right, so now we get to talk about one of my favorite phrases in all of mathematics, and that is SOH-CAH-TOA. SOH-CAH-TOA, this is a little kind of a mnemonic memory aid to understand or define trigonometric functions, sine, cosine, and tangent. So the sine of an angle, all right, sine is equal to the opposite over the hypotenuse. So that's O over H. Now, the O, okay, in our case is going to be the y-axis. So here is our angle, okay. Now, this is where I need to really kind of talk about something called reference triangles, okay. So we have this angle right here, but the angle that we're talking about in terms of sine is right here, okay. It's this angle. So you might be saying, how does this work, Mr. YouTube Math Man? I don't know what this angle is. Well, here's the deal. This is the angle in question. But if we figure out the sine, for example, or sine, cosine, whatever, of this angle, this is the reference triangle, it's the same answer as figuring out the sine of this angle, okay? So here, this angle is what we're talking about. So when we talk about the sine of this angle, it's the opposite. Now, the opposite is this of the angle. This is the opposite side, okay? That opposite side is what? It's on the y-axis, okay? So the sine is opposite over y over h. H is our r, okay? That's our hypotenuse, or r. So we really want to define sine as the sine of an angle as y over r, okay? So hopefully that makes sense, and then we can just kind of go through the rest of these right here. Cosine is adjacent, so the adjacent side is this side right here over the hypotenuse, and tangent is the opposite over the adjacent. Now, if you don't understand basic right angle trigonometry or trigonometric ratios or functions, this video might be, I don't want to say too much for you, but you probably want to start at a little bit more basic level, but stick with me anyways, because if you're like, yes, I think I understand, Mr. YouTube Math Man, well, that is fantastic. Okay, so right here, we're going to define these trigonometric functions as the sine of an angle is equal to y over r. Okay, so we already talked about this is y, this is r, and this is x. Cosine is x over r, and tangent is y over x. So this is the way in kind of more higher level trigonometry we define sine, cosine, and tangent. But again, it's the same thing as opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. All right, so here, if we wanted to find the sine of this angle, what would be the sine of this angle? It's just y over r. So y is what? It's 4. Okay, so the answer, let's go ahead and write this in. So this is going to be 4 over r. So that's 4 over a positive. Now we got to be very mindful on the signs. This is a positive 4, so this is going to be 4/5. What is cosine? Well, cosine is x over r, but x is -3, so that's going to be a -3 over 5, okay? And then tangent is going to be y over x, so that is going to be equal to 4 over -3. So the main kind of point here is when we are talking about angles in trigonometry, we have to put those angles in standard position, okay? And then we need to understand the initial side and terminal side. We need to think about the reference triangle. We need to build out a right triangle and use the Pythagorean theorem so we can get all sides of this right triangle, and we need to be super mindful of the signs of y and x. R will always be positive. Okay, the hypotenuse will always be positive. All right, so let's go ahead and move forward here. and talk about our actual problem. All right, so here's 315 degrees. So, if we want to write 315 degrees or think about it on the XY plane, we need to start with the initial side. Okay, so the initial side is again on the positive x-axis. So here's the initial side, and we're going to start. We're going to go round, around, round, around this way, counterclockwise. And now here we have our terminal side, and it stops in the fourth quadrant. All right, so this is 1, 2, 3, 4. And we got to do a little basic math here because the sum total, if you do one lap around the XY plane, one full circle, that's 360 degrees. But we went 315 degrees, right? So we went 315 here. And if we subtract away 270 degrees, okay, we can reason through and figure out that, well, there's a couple different ways you can do this. You can do 315 minus 270. That's going to be 45 degrees. Or you could just go, well, if we went 360 degrees, we would make a full lap, but we only went 315 degrees. So this angle right here is 45 degrees, right? This is really important to kind of construct this setup, and you cannot do this properly unless you understand where the initial side is and the terminal side is of an angle. All right, so once again, we're not starting our angle over here and going this way or over here and going this way. We started on the positive x-axis, again, initial side, going to the terminal side, and then we want to think about a right triangle. Now, these right triangles will always emanate down. In other words, from here, here's our terminal side, here's our initial side. So basically, we're going to go down to construct a right triangle. Now, what we need to do is start putting in some information. We have a 45 degree, 90 degree right triangle. So if this is 45 and this is 90, what do you think this is? Well, if you say, hey, Mr. YouTube Math Man, that's awesome, 45, well, you're definitely on to something. Now, I got a little note right here. I'm saying, hey, notice, because this is going to be really critical, that this x right here on this triangle is positive, but the y part of this right triangle is negative, okay? And remember, our radius will always be positive. So we have a 45, 45, 90 degree right triangle with positive x and negative y. All right, so let's go ahead and take the next step, and that is to build a lovely right triangle that represents what's going on. Okay, so remember we had 315 degrees. It went around this way, and we're trying to find the sine. But if we find the sine of this angle right here, this 45 degrees, we will have answered the question. Now, you can have negative angles. Those would go this way. But basically, this is where our problem is pretty much distilled down to. Okay, so we have a 45 degree here, 45 degree here. Now, we are dealing with the 45, 45 right triangle. Okay, so 45 degrees, the sides are the same. Basically, what we have here is a square, and it just kind of, the diagonal cuts it in half. So the sides are the same, so we have positive 1 on the x and negative, remember that y is negative, so we have negative 1 here. And then we can use the Pythagorean theorem to figure out that the hypotenuse is the square root of 2, or if you just understand 45, 45 right triangles, you know that the hypotenuse is always x times the square root of 2. So in this case, it's just 1 times the square root of 2, or the square root of 2. Okay, so we have all the sides of our lovely right triangle, and we have sine, cosine, and tangent. We understand what those ratios are. So remember, we wanted to figure out what the sine is. So this should be pretty straightforward. Let's go and take the next step, which of course is having you quickly subscribe to my YouTube channel before I finish this problem up. Now, I definitely need your help in order to grow my YouTube channel. Okay, I put a lot of thought and considerations into these videos. I've been teaching math for years, and I kind of know where students typically tend to get confused, especially, when it comes to, various levels of math. And in trigonometry, if you don't understand what I'm talking about here, you're going to have a tough time in that course. But if you can understand, basic reference triangles, initial side, then you know what, things are going to go much smoother for you. And the main point is when you are learning math, all right, math builds upon itself. So if you are going through this kind of journey and you struggle with something here, you're like, oh boy, I'm totally lost. Oh, I don't really get this. Well, you just can't ignore these things because they kind of build up and eventually you kind of hit a brick wall. So the best way to study math is to identify your weak areas, what you don't know, and then work on those, improve those, and everything is going to get much, much better. But in order to really understand and overcome things that you don't, get, you need great math instruction. So if you need additional help beyond this little video in terms of trigonometry or geometry, check out my full main pre-calculus course. I'll teach you everything you need to know about basic trigonometry and advanced trigonometry. All right, so let's go ahead and finish up this problem. And what we have here again is our right triangle. So this distills down to this right triangle right here, and we have to be very aware of the signs of the sides. So this is +1, remember on the x, -1 along this y, and then always a positive radius or the square root of 2. So 45, 45. Now remember the sign of an angle is y over r. So here, what's y? Well, y is -1, and what's r? That's the square root of 2. So we have -1 over the square root of 2, but we don't want to leave our answer that way. We have to fix it up. Remember, we don't want to leave a radical in the denominator. So this is pretty easy. All we have to multiply, or all we have to do is multiply the numerator and denominator by the square root of 2, and we get the square root of 2 times the square root of 2, which is the square root of 4 or 2, and -1 times the square root of 2, which is negative square root of 2, or negative of a positive square root of 2. So this is the correct answer. Now, if you turn this into your teacher on some sort of trigonometry exam, they're going to take points off. They're not going to like that because, in trigonometry, if you're taking trigonometry, you're already at the point where hopefully you have the algebra skills or you learn the algebra skills because you're currently in trigonometry. So again, math builds upon itself and you cannot forget those skills, right? When you're in algebra, you got to remember your algebra for geometry. There's a lot of algebra in geometry, and there's a lot of algebra and geometry in trigonometry, right? See how that goes? So, I think the lesson here is have an attitude of long-term comprehension. So, in terms of mathematics or anything you do, because everything is going to build upon itself. A lot of times people they take a short-term view of math. They're like, I just need to know enough to pass my test, and then I'm going to totally forget it and then move on to the next thing. That is not a good approach. And typically, you're going to get frustrated and not do well. But if you take the attitude of like, all right, let me really learn this for the long run, even if you don't like it, if you take that attitude, you're just going to be much better served in your entire math, adventures. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.